Today we'll see the problem based on two heaps. We have already seen this problem in a previous video, so that's the video you can find in the playlist logic building, and this video is going to be long, so if you have not understood the problem you can come back, but we are going to solve this problem again using the golang. So we'll understand first, find a median from data stream. This is hard problem, but if you are familiar with the data structure, max heap or main heap, then it's not going to be hard. So let's understand this problem, and then we'll write to the code, and I will use golang, for the solution. So the median is the middle value in an order integer list. If the size of the list is even, there is no middle value, and the median is the mean of two middle values. So in example, you can see in this case this number is 3, 1 2 3, so that's odd, so this middle one is the median, so that's the answer is 3. And in this case it's a two numbers, that's the even number, then we can take this number and this number, add that, and then divide by 2. That's a median. So if you have some fixed number like 2 3 4, then it's very easy to find the median. But in this example, this numbers, this array is not fixed. It's saying that, okay, find median from data stream. So now it's a 2 3 4. There can be another number added, and then we have to find the median, another number added, find the median. So it's a keep growing, and we have to find the median. So let's see what's the algorithm we are going to use. So let's move to the another screen. Okay, so the way we are going to solve this problem is we create first two data structure. So step 1, create two heap, that is max heap and main heap. That's a step 1, we'll create that data structure. Step 2, we add the number in max heap and main heap. So the algorithm to add the number in a max heap is, let's say we get 2, so as soon as we get 2 we add to the max heap. So this is the max heap and main heap. So we get 2, and we'll check if there is no item in max heap, we'll add the item in a max heap. So that's the one condition. And other condition, to add that in a max heap is, if there is already a number here in a max heap, then we check if this item is less than the top item in a max heap. If it is less than, then we can put it here. So the first thing, the max heap logic. So max heap logic is if it is empty. If it is empty, add item. B, if new item less than top item of max heap. So in that two condition we can add in a max heap. Otherwise, the number goes to the main heap. So that's the one thing. So step 2, we add the item here. Step 3 is rebalance two heaps. So way to the rebalance is, we'll check the max heap so logic is max heap greater than length of min heap plus 1, min heap plus 1. So this is length of max heap. So that's the logic to rebalance two heaps. So in this case, like if you see, the max heap length is greater than min heap length plus 1, then what we do, we take one item from the max heap and put to the main heap. Otherwise, we take the item from main heap and put to the max heap. So let's analyze, some of the scenarios here. So in this case, we got 2. So we put that based on these two conditions. We check, okay, if it is empty, so max heap is empty here. So first we put the 2, then rebalance 2 heaps. So we'll check the length of max heap. Length of max heap is 1 because there is one item, and main heap is just 0. So 1 is greater than length is a 0, 1. So this is not true because this is also 1 and the length is 0 plus 1, 1. So both are equal. So we'll not do anything here. We get another item, 3. And then we'll check, first thing is if it is empty. So okay, max heap is not empty. Then we'll check, okay, 3 is less than the top item of max heap. 2, 3 is less than 2, no. So 3 goes here. Again, we'll check, we'll rebalance 2 heaps. As soon as we add the item, we have to rebalance. Okay, rebalance 2 heaps. So we'll check length of max heap. This is a 1 greater than length of max heap plus 1. So this is 1 plus 1, 2. So not greater. Anyway, so we'll not do anything here. So, but another piece of logic I forgot to add. If else condition, else if length of min heap is greater than max heap. So in that case we'll move item from min heap to the max heap. So till now we are fine. Let's take another item, 4. So we'll come here and we'll check max heap is empty. No, it's not true. We'll check 4 is less than 2. No, it's not true. So 4 goes here. So I'll just put the 4 below because we know, the top item in the min heap will be the minimum item, and that's a 3. Rebalance the 2 heaps. We'll check the length. So length is 1, and this condition is not going to be true. 1 is greater than 2 plus 1, 3. No. We'll come back here. We'll check min heap is greater than max heap is. So if in this scenario, what we'll do, we'll move top item from min heap to max heap. So the 3 goes here, and 3 is the higher than, it's a bigger number, bigger than 2. So I'll put it here, and just it will delete from here. So deleted. So the deleted item. Okay, so that's all. And once we add all the item, then we have to find median. So the logic for finding median, logic for finding median. So in this case, we'll check a length of max heap and min heap. So if the both are equal, then we'll take top item from here and top item from here and divide by 2. And if it is not equal, then we'll take top item from the max heap, and that will be a median. So our pattern in the max heap and min heap will be like this. If this is the odd number, then the median will be always the top item of the max heap. If it is the even number, then the length will be same, and then we can take the top item from max heap and top item from the min heap and divide by 2, and that will be the answer. So I already explained this, and then we'll see the code. So I'll just write this algorithm also. If length of max heap and length of min heap is equal, then max heap top item plus min heap top item divided by 2. That's going to be median. If both length are not equal, then top item of max heap will be median. Okay, so we learned this logic. Then let's see the code, and when we see the code, it makes sense. Okay, so first step is create two heaps. That is the max heap and min heap. So let's do that. Okay, so there is already a code for min heap, and in order to create a max heap, I can just copy everything from here to here, paste it here. So this is the min heap, and make it max heap here. Max heap. No, that's the main. You have to change here. Change this also. And you can also watch the previous videos where I have explained this the function, how to implement this function. So max heap, and for the max heap, one thing we have to change this less function. So if I change to the greater than, this turns to the max heap. Okay, so our two data structure is ready. Init main heap is ready, and the max heap is ready. Okay, we'll use same function in a leetcode, whatever we have used. So let's go to the leetcode. We know there is a constructor, so we'll use the constructor first. There is a struct also. So let's copy the function, and then we'll implement the function. Median finder, so that's a struct. Median finder, that's a struct here. So we have the max heap, init max heap, init main heap. So in this struct, we created these variables here. The next thing is, come back, we need a constructor. So we'll see how this is going to work, this constructor. So median finder is a constructor where we have initialized this, but we'll find the way how to call this function. So come here, the way there is a okay, let's copy this all the function, then we'll come back and we'll try to understand. So this is logic. Let's copy this. Put it here, and we'll come back and we'll see the logic, how it's going to work. So in the main, the way we call is, we'll call this is, first we create the object. So let's copy this also. We'll come back and analyze the everything. Okay, so the first thing we have called the function called constructor. So let's see what is in the constructor. So in the constructor is a function, and this is the struct. So we are going to return a struct here. So this is the struct we have created, and in this struct we have put the max heap and min heap, and we have initialized the max heap and min heap. So this is the way to initialize max heap and min heap. Okay, so this constructor we have called here. So create the object. Now with help of this object, we are going to call add num. So let's make it in a for loop here. So let's copy this data. This is 2 3 4. Come back to code, and I can create an array here and put it 2 3 4, and this is the object, and then I can iterate through array, range a, okay. So here we'll add the numbers. So we'll iterate through this range array. So we'll get the first 2, then 3, and then 4. So as soon as you get the item, so I put it here, add num. So as soon as I add the item in this add num, then we'll have the logic for adding the number. So the logic is how to add the number. So the logic is here, we have already explained. So step 1, that's done. So step 2, we have to put the item in a max heap, and then step 3, we have to rebalance 2 heaps. So this step 2 and step 3, this two piece of logic is inside this add num. So we'll check that, how we are checking. Let's see. So we got the number here, and we are checking here. It's a max heap length equal to 0. If it is length is 0, or this number is less than top item in a max heap. So this is the way to get the top item from the heap. So if this is the case, then push the item in a max heap. So that will put the item in a max heap. Otherwise, we'll put the item in a main heap. So we are using this. So this refers to the object. So we know the add number will be called. This is getting called by object, and this object we created based on a constructor, and we know the constructor return something. Constructor return the median finder, this object. So that's why the median finder, this is the object, and with this help of object we can access the max heap and also access the main heap. Okay, so the first logic is done, how we are adding the number in a max heap, and then the second thing is rebalance 2 heaps. So rebalance 2 heaps is we are checking max heap length greater than min heap length plus 1. Then in this case, we pop one item from the max heap. So this is a max heap top item, and then we can put to the main heap. Otherwise, we can check, the max heap length less than a mean heap length. So that means the mean heap is the higher. This has the more numbers. Then we can get top item from the main heap. So this is the way we can take the top item from the main heap, and then you can add the top item in a max heap. So in the max heap we are adding the item. So rebalance logic is done. So in this way we call the function, we call this function, and then we can add all the number. And we have to, if you want to find out the median, we can call this function here itself. As soon as we add the number, because this is the stream, so as soon as we assume that number is coming and we want to find the median, so we can print this. Median. Okay, let's see the logic for the finding the median. So we are checking the length of max heap and the mean heap. If both are same, if the both are same, then take the top item from the max heap and the top item from the mean heap, and then divide by 2. So that's a median. Otherwise we'll take the top item from the max heap, and that's the median. So let's run it. Okay, we'll see the 2, because we added 2, so the median for 2 is 2. So that's fine. That's why the 2 is the median. And we add the 3. In the case of 2 and 3, it's a 2, 3, 5, and 5 divided by 2, so that's a 2.5. so that's the median. And as soon as we add the 4, then in that case 3 will be the median. So 3 is the median here. So that's all about this logic. Okay, so that's all for today. See you in the next video.